Hope you guys had a good week. I've noticed that some people haven't quite finished the homework yet. That's OK. It's due tomorrow. You still have some time. Most of you guys seem to have done fine on it. There's those of you who are still in like the 20% complete part, kind of need to step it up maybe by tomorrow, but you'll be all right. And do email me if you have any questions about that stuff. So tonight we're going to do a few things. We're going to work on a couple different sections. Hey. All right, a couple more people showing up here. Hey, Nadia. Hey. Hang on. All right. And Rolando, right? Yeah. All right. Truth, where are you going? You have to start over. All right. Well, anyway, so as I said, if you haven't finished the homework up, it's due tomorrow. Today, we got four things to do today. Thing number one, we're going to do a few of the sections, get those out of the way. And then thing number two, well, I guess thing number 1, 2, and 3 are the 3 sections we're going to do. And then after that, we're going to go over the practice exam again. For those of you guys who were here the other day, if you want to stick around again on Thursday, you're welcome to. We'll go over as many problems as you want. And then we will be ready for tomorrow's quiz. Right? I will reiterate, for the quiz, it is going to be 50 minutes long, which is plenty of time. I think the first quiz especially, it's plenty of time to do that. But if you do need extra time, you can stay after class and finish up. I'm not worried about the time part of it. I'm more worried that you know how to do the stuff, which is the tricky part in terms of understanding the material, right? That's the important part. So there he is. All right. How's it going, Dominic? All right. Let me get this down. All right. So we are now already, I should say, into algebra. Okay? And some of you guys might cringe at that because you probably didn't like it in high school. A couple people said they did like it in high school, but maybe didn't try as hard as you could have. But algebra is basically the manipulation of numbers and symbols so that we solve some problem for one of those symbols. Okay? We're going to start with algebraic expressions. Okay? And when I talk about an expression, okay, I mean a combination. Write this down. A combination. Did I spell that right? Combination of these things called variables, okay, numbers, okay, and operations, and the operations of addition, okay, subtraction, I'll abbreviate, subtraction, multiplication, division, okay, and powers and roots, like we've been doing so far. Okay? And when you have a combination of these things, okay, you have what's called an algebraic expression. Okay, an algebraic expression. These do not have equals signs in them quite yet. Okay, algebraic expressions, no equal signs quite yet. Okay, if we say evaluate the algebraic expression, what that means is solve for some value, some letter or variable. Okay, straightforward. Here's an example. Okay, let's say we have 3x plus parentheses x minus 2 squared for x equals 5. There's an equal sign over there, but this part is the algebraic expression. Okay, this part is the algebraic expression. And what we're trying to do is we're trying to say, what does this mean if x equals 5? pretty straightforward, really. Because what you're doing is every time you see x here, you're going to just plug in 5. Okay, that's all there is to it. If you see x here, you plug in 5. So let's do that. 3, there's an x. I'm going to generally put them in parentheses just to show that it's like multiplication in this case. I'm going to put a 5 there, plus, I don't need a parentheses there, 5 minus 2 squared. All the x's are filled in with the number. And now I just solved this like we had to do for what we had to learn last week with the correct order of operations. First thing we do, 3 times 5 is 15. Okay, plus, then we do the parentheses over here. 5 minus 2 is 3. Still got the squared. 15 plus 3 squared. So the next thing we do, 3 squared. So we get 15 plus 9. And then finally, we're left with 15 plus 9 is 24. And there's your answer. OK? So far, so good? Just plug in what you've got. If I change this to for x equal to 4, I would put a 4 there, and then solve it, and it'd be just different. So, I mean, it'd be the same exact thing, but we would just solve it with a different number. OK? That stuff is not too bad. OK? Let me do another one. OK, we're going to practice lots and lots of these. OK, lots of these practice. OK? So let's see. X squared minus 5x plus 6 for x equaled -3. OK, let me show you how we do that. We plug in -3. Now, wherever x is, that's the number that goes there. So this says x squared. That means it's going to be -3 squared. -3 squared or -3 squared. Which one is it? This one? Well, no. Because the squared is for all of that x. X, in this case, happens to be -3. So we're taking that and multiplying it by -3. Because that's what x is. So it's got to be the top one here, right? So anytime, that's why I put the parentheses in when you have things like this. Because a lot of times you'll forget that, and then you'll get it wrong.
What's the difference with the other one then?
-3, whoops. Sorry, -3 squared?
Yes.
That's -3 times 3, which is -9.
Okay.
Versus this, which is -3 times -3, which is +9. OK? That's one of those ones that a lot of you guys will forget it and get points like taken off quizzes because you'll get that part wrong. Again, if you did that wrong on this one and you did it the other way and you did the rest of the problem right, I'd take 1 point off. But like somebody said the other day, I need all the points I can get. Right? So try not to forget that sort of thing. OK? All right. So we've got that. Now let's do the next one. -5x, or minus 5x. Minus 5 times -3 plus 6. Same sort of thing. In this case, you're gonna find out that it's going to be negative. You're going to do like -5 times -3, or 5 times -3, but you're going to leave the minus sign. I'll show you. Let's see. First thing we would do is this one. What's -3 squared? 9. +9. I'm going to write down the minus sign, because that's the way I like to do it. Minus 5 times -3 is what? -15. So I'm going to write it like this. 9 minus -15 plus 6. OK? See how these two are going to now cancel each other out in the sense? It's going to become plus 15. You could have done it that way before. -3 plus 15, because it's going to be -5 times -3. That's fine, but you got to remember to change the plus. That's another one where a lot of people get it wrong. They just forget and do it incorrectly. Anyway, 9 plus 15 is 24. 24 plus 6 is 30. OK? All right. Try this one on your own, unless there's any other question about that one. OK. All right. OK, try this one. Try x plus 5, the whole thing squared, minus 4x plus 6 for x equal to -4. And you can use your calculators for this. but you're going to have to, you should definitely show me some work. You probably could type it all in your calculator at once, but I would show me the work first. Okay, try that one. I'll start writing it down. Good. What part did you forget? Okay, good. And again, if it takes you a little longer than what I'm doing on board, fine. I'm not worried about that. Just make sure you get the idea down so that you can recreate it when it comes to the next quiz. Everybody get 23 on that one? Okay. Any questions? Anybody mess up and say, oops, I accidentally did minus 16? Anybody do, I don't know what you do here. You could have done 4 minus 5 and gotten -1 or something like that. And I kind of did an extra, I skipped a step here, by the way. -4 plus 5 is 1 squared. So there's really an extra step in there, 1 squared, which is just 1. Okay. Hey. All right. Any questions on that one? OK. I'm going to show you something on the projector up here. OK. How's it going, Dave? Good. Let's see. Dwan walked in as well. OK. Tony here? Tony's not here, is he? No. All right. I'm going to show you another problem here that showed up on the last final for the last semester. Very similar problem to this. Okay. Let's see. It's a little tough to see here. Do that. And we'll do this. OK. All right. See this graph here? A bunch of problems on the final are going to be based on things like this. Okay? And what the problem will do is it will explain what, I don't want to clean the filter. I just want you to go away. It will? OK. What this graph right now tells you the calories needed to maintain energy balance, whatever that means, okay, for moderately active lifestyles. In other words, if you're a normal person that doesn't work out 400 times a day to train for triathlon or something, this is how many calories you need. Okay, based on your age group. This is the graph of this. And what they do, they just chart it out. So for instance, when you're 4 to 8 years old, girls and boys both need about 1,500 calories. Okay? But when you're 9 to 13, boys actually need about 2,000 versus 1,800 for girls. And obviously, this is all averages and so forth. Okay? What we have is we have the data here. But there's actually a formula that somebody, an algebraic expression that somebody came up with that charts this, that makes it so we can get this data close to this data anyway. Okay? Here's what it says. It says for women, W, and a lot of times you'll label things for with the variable that makes sense for what you're trying to do. W equals -66x plus 526x, okay, plus 1,030. 1,030. Okay, sorry, 66x squared. Okay, hey there, how's it going? Okay, 66x squared. So this means that this describes the number of calories needed per day by women in age group X. And notice I've labeled the groups here like this. Okay? So there's a question that goes along. It says, according to the model, this is the model. Where did they get these numbers? Well, don't worry about that so much, right? I don't have no idea where they got those numbers. They basically looked at the chart here and figured out how to get this formula. But what it means is if you plug in the group, you should get numbers close to the numbers for the women here. OK? All right, so here's the question. It says, according to the model, how many calories per day are needed by women between the ages of 19 and 30 with this lifestyle? Okay? We're going to use the model to figure it out, and then we're going to check and see if our graph is pretty close and which one is over or underestimated. Okay? So 19 to 30, what group is that? 4. So what we're going to want to do is we're going to say evaluate this for x equal to 4. Okay? Because that's what the problem said. And this is part of the word problem stuff that you're going to have to be able to understand. When it says, here's the model for this set in group, where x is the group. Well, that's where you have to pick out, oh, I see. This is the group. That means x is 4 or x is 5 or whatever. So in this case, x is 4. So what we're going to have is w equals negative 66 times 4 squared. Sorry, I'm running out of space. Plus 526 times 4 plus 1,030. Do that in your calculators. Anybody not have a calculator? There you go. You guys forget your calculators today, or are you? There you go. Somebody else? OK. Oh, there you go. Yep. All right. So, anybody figured it out yet?
2078.
Hang on, negatives. I'm going to try mine too. Negative 66 times 16 plus 526 times 4 plus 1,030. What did you say it was? 2078. 2,078 calories. Okay? If you didn't get that on your calculator, try again until you do. Okay? One of the tricky ones might be doing the negative 66. You're not going to do the minus button. You're going to do that button in parentheses, negative 66. Okay? All right. So the model says for women in age group 4, they should get 2,078 calories per day. Does the model overestimate or underestimate what the graph tells us? I hear one person said it. Does the model overestimate or underestimate what the graph tells us? It underestimates it. Why? Because this is what we're looking for. The graph says 2,100. The model says 2,078. And if I asked you how much, by how much, you'd subtract, right? 2 by 22 people. Or, sorry, 22 calories. Okay, 22 calories. This is the kind of question they will ask that we'll find on like the final or one of the tests. Okay, a very similar question to this where you've got to look at the graph, you've got to look at a model, figure out the model, apply it to what the graph says, and come up with how much it's over or underestimated. Okay, why do we ask these things? Because this is the kind of thing you might see in a newspaper or something. You probably won't see the formula, but you never know, right? Things like that they want you to be able to get to see. Yeah.
So that's
Rolando.
the standard formula for figuring out this type of equation.
According to our book.
Okay.
But yeah, sure. So go ahead.
Are we going to be required to memorize?
No. You will not be required to memorize. You'll be required to memorize like 2 things in here. The quadratic equation, which we'll get to next week or the week after, and maybe 1 or 2 other little things. And you'll have a formula sheet. But for a question like this, it will absolutely give you this. Okay? You just have to know, OK, when it says group 4, and they say group is x, oh, I'm going to be solving for x equal to 4. That's the part that you got to figure out. OK? All right. Any questions on this one? OK, good. All right. OK, so now that we have algebraic expressions, OK, we've also got algebraic equations. Okay? I think it said formulas before. I'm going to call it equations. Okay? Algebraic equations you will see all the time. Okay? This is two algebraic expressions with an equals sign between them. Okay? For instance, 3x plus 9 equals 3 times x plus 3. Okay? See how there's an equals in there? And what we might want to do is, you might in this case want to solve for x, although this isn't a very good example, right? But we'll get to more problems like that. Okay? Here's another one. 3x plus 9 equals 15. Is that an algebraic expression? Sure. Is that an algebraic expression? Sure. It doesn't have to have a variable to be an algebraic expression. Okay? And then there's going to be an equal sign in there. Okay? So we're going to talk about how we actually get to solving that in a couple minutes. Okay? This is what?
No, I'm doing it in my head.
Oh, you're doing? Yeah, go ahead if you want to. Okay? So when we talk about algebra, okay, algebra is just a way to describe the world. Just like we had that equation or that expression up there before to explain the number of calories or to model the number of calories you might need in a diet. Okay, algebra is basically the way we explain the way one of the ways we explain the way the world works. Okay? All right. We have to talk about a little bit of vocabulary here before we go into some of the details of solving these things. Okay? If you have this 7x plus negative 9y, and I'll put that in parentheses. Really, that is same as saying minus 9y, but I'm writing it this way for a reason. Plus negative 3, same thing. Okay? These things are called terms. 1, 2, can't do upside down curly brackets. These are all called terms. That's a term, that's a term, and that's a term. Okay? The reason I'm giving you the vocab is because when I say, look, let's look at this term, you'll go, oh, I get what that means. Okay? In this term, okay, and a term is something that's separated by basically an addition. Okay? It could be a subtraction, but remember, plus negative 9 is the same as minus 9. So you can always convert it into an addition if you want to. Okay? In this term, okay, this is called the coefficient. Okay? And this is just called the variable. Okay? The 7 is the coefficient. The x is the variable. Okay? We don't write some coefficients. X minus y plus 3. What's the coefficient of x? 1. We just didn't write it. Okay? You can write it if you want to, but you don't need to, and you won't see it that way on almost all the problems. Okay? There's no variable for this term. Okay? It's only a coefficient. It's just 3, just the number 3. Okay? All right? What's the coefficient of y? Careful. Negative 1. Even though it looks like it's just 1, this, remember, could be rewritten x plus negative y plus 3. So the coefficient for that term, which is separated by additions, is negative 1. So you got to be careful. We don't write the negative ones either. Okay? And this is just the constant. OK. Let's move on to some more basic stuff about this stuff. All right. Terms that are what we call like terms, okay, have the same variables as factors. So watch this. 7x plus 3y. Do they have the same variables? No. Okay, so not like terms. Minus 4x squared plus 12x minus 8y. OK. I kind of almost misled you a little bit there. 7x and 4x squared. Although they have the same variable, the fact that it's squared here and not here means you can't add those together. You can't combine those. Remember, it was the same as when we did, this is going to be on the test tomorrow, right? 4 squared plus 3, or I don't know why I'm doing this. 4 squared plus 4 to the third. You actually can't add those together because they're different. They're the same base, but you can't add the you can't add them together because the exponent is actually different in this case. Okay? All right. So in this case, we can't add those. So what we can do is we can say which ones are the like terms. Well, here's a like term, the 7x, and I'll write it this way, the 12x. Okay? So we can add those together because they are like terms. Okay? Here's some more like terms, the 3y and the negative 8y. Also like terms. Okay? And we are going to combine them when we actually do these. Okay? When we combine these, okay, we say that we simplify. Okay? We simplify the algebraic expression. It's kind of like when we simplified the square roots that we were doing the other day. Okay? When you remove all the parentheses and you combine the like terms, then you have simplified things. Okay? So we can simplify this if you want to. 7x and 12x is 19x. The 3y and negative 8y are going to be negative 5y because 3 plus negative 8 is negative 5. Okay? And then the last thing, we didn't have any other like terms, so we'll just leave the 4x squared, negative 4x squared in there. So now I've simplified that algebraic expression. Okay? A lot of this stuff you're going to be like, yeah, I get it. You got to know this stuff really well, because if you don't know it really well, you won't be able to remember how to do it, and then I'll ask a problem that involves this, and you won't be able to do it. So get these ways we do things down as best you can. OK, let's try this one. 3 times, in parentheses, x squared plus 2x plus 7 times 3x squared plus 2x. Whew. Let's simplify this. Okay? To simplify, we've got to get rid of the parentheses. What do we call it when we make the 3 times this and times this? What property is that? Distributed property. So we're going to have to do that here. 3 times x squared gives you 3x squared, and 3 times 2x gives you 6x. Okay? We do the same thing here. We have to distribute the 7 through here and here. So this is going to be plus 21x squared plus 14x. All I did was multiply both those terms by 7. Hey, Tony. All right. Are there any like terms here I can combine?
Yes.
Sure there are. There's the x squared, and then there's the x ones as well. 3x squared and 21x squared, when you add them together, gives you 24x squared. And then 6x and 14x, 20x. And that is simplified. There's nothing else you can do with that. Okay? You could factor out some numbers, but don't bother. It's no parentheses left, and all the terms are there. Okay? All right, let's try another one. Okay, let's see. Let's try this one. 3x plus 5. I'm going to put a big bracket here because I'm going to have another parentheses inside it. 2 minus, x plus 4. Okay. All right. Remember our order of operations. We have to kind of go from inside the parentheses to inside the other parentheses before we can do any of this stuff out here. Okay? This one is another case. It's like stomp your foot time, right? This is another place where you will forget this if you don't remember it now and start practicing this. This minus is actually minus 1. Okay? So this really says 2. I wouldn't really draw it like this, do it like this, but negative 1 times x plus 4, like that. What does that mean that the negative 1 has to do to this parentheses here, the things in here? It has to distribute through here as well. So this actually becomes 2 plus, well, I'll do it this way, 2 minus x, because negative 1 times x is negative x, minus 4. like that. Okay, and I'll put the rest of this in here, plus 5. Okay. Everybody get what I did here? I did the -1, distributed it through here. Just like I would any other, if it was a 5 or whatever, I'd still distribute, or -5, I'd still distribute it through. But the -1 made this x negative x, and it made this 4 negative 4. Okay? What can I do next? Distribute the 5 through all of these terms. It doesn't have to be just 2 terms. It can distribute through all of them. This is going to be 3x plus 5 times 2 is 10. 5 times negative x gives us negative 5x. And 5 times negative 4 gives you negative 20. Okay. Are there like terms?
Yes.
There are. 3x and negative 5x. Negative 2x. And then 10 and negative 20? Negative 10. And there's your answer. Okay. By the way, this little yellow paper means we finished a section. Done. All right. Any questions on algebraic expressions or equations? We haven't really gotten to the equations part yet. Yeah, Rolanda.
I don't know why I want to do this every time, but can't you divide it by -2? Can you divide it by the answer?
OK. You want to divide this by -2. You can't, because that's an expression by itself.
Okay.
Right? Which tell you what. Let's solve this. Let's practice this. For x equals 3. What does this equal for x equals 3? -2 times 3 minus 10. And by the way, always write it down so I know what you did. Like doing that part gets you points. Right? -2 times 3 minus 10 is going to be equal to -6 minus 10, which is -16. Okay? So far, so good? If you divided both sides by 2, because 2 goes into both, you would end up with negative x minus 5. Right? Because you divided both sides by 2. Sorry. No, you said divided by 2, right?
No, I meant.
Oh, divide by -2? Fine. Divide by -2? Sure. You'd be left with x plus 5. Let's solve that for x equals to 3. 3 plus 5 gives you 8. Did we get the same answer? No. So you can't do that from just expressions. Okay? There are times when you can do that when they're fractions and so forth. But really, fractions, you haven't quite simplified it all the way. Okay? Yeah. Don't do it again. Good. Good question. Okay. All right. All right. Let's knock out to the next section. And all right. Hopefully this stuff isn't too horrible yet. And yet, well, some of you guys will eventually go, this stuff's kind of tricky, but it'll be all right. We'll make it. Okay. 6.2 is what we call linear expressions. Okay, linear expressions in one variable. And they also throw in some stuff about proportions. Proportions are like fractions or when you're comparing one thing to another. Okay? Okay. A linear expression in one variable means an equation is an equation that can be written in the following form. ax plus b equals 0. Okay. A has to be real, b has to be real, and a can't be equal to 0. Because then it wouldn't have this part in there at all. It would just be b equals 0, which means b would have to be equal to 0. And that's kind of silly. So in this case, ax plus b equals 0. That's a linear expression. Okay? 3x plus 12 equals 0. Is that a linear expression? It is. Anyone know what linear means? It's got the word right in it. There you go. Jeremy's saying line. Okay? A linear expression means that this equation, well, this one isn't really, this one's not really a very good example because it should have a y in there. But It means that these are equations that will define lines in some sense or another. Okay? In this case, they just define actual like flat lines. But okay, x has to appear in these, and x can't be raised to any power either. Okay? It can't be like ax squared. Different ones we'll get to later. Okay? So this one's definitely a linear equation in one variable. Is this a linear equation in one variable? 2x equals 5. Yes, but not quite yet. Yeah. This actually, if we, we'll do one step of algebra right now. If we subtract 5 from both sides, if this is equal to something and the other side is equal to something, and we subtract the same thing from both sides, aren't we left with the same answer? Sure. So I can subtract 5 from both sides here. 2x minus 5 equals 5 minus 5 is just 0. 0. Is it now in the form 2x, well, ax plus b? Almost. 2x plus negative 5 equals 0. ax plus b equals 0. Now it is. So yes, that's an equation that is a linear equation in one form, or in one variable, because you can turn it into this form. Okay? I won't trick you with those kind of questions, but yeah.
Do that last little part on the test,
Do the plus negative 5? No, you won't have to. I mean, I won't make you do these in this case. Okay? Let's look at another example. And I'll tell you right off the bat that this is a linear equation in one variable. 4x minus 12 equals 2x plus 7. Same idea. Do we only have x variables that don't have exponents and everything else is just a number? Sure. Okay? You could do this. You could get the 0 on that side too by subtracting the whole thing by negative 2x minus 7. Or adding, I should say, or whatever you want to call it. Minus 2x minus 7. If you did the same thing to both sides, 4x minus 2x gives you 2x. Negative 12 minus 7, negative 19 equals, well, 2x minus 2x is 0, and 7 minus 7 is 0, 0. Okay, so now it is changed in that form. We will do lots of that manipulation to practice. Okay? All right. What we're doing is getting to the point where we are going to do what we call solve the equation. Okay? Solving an equation is basically saying find all values of x that make this statement true. Okay? Solving equations. Okay? Find all values of x that make the statement true. That's what we're doing. Okay? We'll get to an example here in a second. What we call those values, okay, we call them solutions. This is more vocab. Or we also call them roots. Kind of a historical reason why they're called roots, but that's what we call them, even though it's not a square root necessarily. We call them the roots of the equation. Okay? 3x plus 12 equals 0. Isn't it true that x in this case is going to be equal to 4? Because 3 times 4 is 12. Sorry, negative 4. 3 times negative 4 is negative 12. Negative 12 plus 12 is 0. So a solution is x equals negative 4. Okay, that's also a root. We also call it a root. We will learn how to get that in a second. You could probably look at this and go, OK, I get it. You got to multiply something to get negative 12, well, negative 4. Good. You're doing that stuff in your head. If you are, no problem, but we got to formalize it a little bit. Okay? We also say negative 4 satisfies the equation. And we actually write this, and this is what you'll see on your homework in particular. We write this like this. There I go again without being able to do this. Whoop, there we go. Negative 4 is the solution. Okay, we write it in these little curly brackets, and that's the solution set. We call this the solution set which is just, in this case, one number. Later, we will get to solution sets that have more than one number in here, or they're null sets, which means there are no answers, or every number, which we'll be able to write as well. Okay? If two equations have the same solution, they are equivalent equations, like they're the same equation. Okay? We call them equivalent, which means they're the same. Okay? 3x plus 12 equals 0 is equivalent to 3x equals negative 12. Why is that the case? 3 times negative 4 plus 12 is 0. 3 times negative 4 is negative 12. Does that make this side equal to this side, so this is the same? They both have the same answer, which is negative 4 for x. Equivalent solutions, or equivalent equations, rather. Okay? The whole point of all this is that we have to get equivalent equations in order to get a solution. Okay? All right. Here's the rules. We talked about one rule a second ago. Okay? The rules for solving these equations. We may add or subtract, okay, the same thing to both sides of an equation. Same thing to both sides of an equation. Okay, that's one thing we might do. Okay. You can multiply or divide both sides of an equation by the same non-zero number. Okay? I could write the exact same thing. We may multiply or divide, and then it's going to be the same thing to both sides. Okay? And the number has to be non-zero. Zero number. I'll show you what that means in a minute. If you tried to do it by 0, you'd end up with like being able to say 2 equals 1 and silly things like that. Okay? When you do these two things, when you multiply or divide both sides of an equation by the same non-zero real number, or you add or subtract the same thing to both sides, you don't change the solution set. And that's why we can do it, because you get like this from this, and therefore they're the same exact thing, and you're not changing anything, which means you're getting towards a solution. Let's do an example. Okay. I will not erase the rest. And in fact, I'm going to write this out explicitly, because I kind of didn't sound very good when I wrote it out. We may multiply or divide both sides of an equation, both sides of an equation by the same non-zero real number. OK. Ta-da. Here is our example. X plus 5 equals negative 12. No, we'll just do regular 12, positive 12. X plus 5 equals 12. Okay? To get x by itself, which is what we're trying to do, you can look at that and you can say, what plus 5 equals 12? Well, 7 plus 5 equals 12. Let's do the actual manipulation based on these rules to get it that way. Well, how about we subtract 5 from both sides? And I will always try to write it like this. You should get used to writing it like this, because A, you get points, and B, you get to see exactly what you're doing. X plus 5 minus 5 gives you x, equals 12 minus 5 gives you 7. There's your answer. Okay? We would write this like this. We would say this. I have to take an art class. We would say that the solution set is 7. Okay? Can I erase this now?
No,
Not this stuff?
not the bottom.
I'll just do, how about this one? All right. Sorry, I'm probably going a little fast. Okay. Here's another one. X divided by 5, in other words, the fraction x over 5, plus 4 equals 6. Maybe we can do this one in our head too. What plus 4 equals 6? 2. What do you have to divide by 5 to get 2? 10. So we're going to end up with 10. Let's try to prove that to ourselves. Okay? In these equations, what you want to do is, especially when you have fractions, you want to do the additions and subtractions first in this case. It's kind of backwards from the other stuff. Sometimes it works out that way, sometimes it doesn't. And it does take a little practice to remember how to do this or to do it for the first time if you've never seen it before. In this case, the first thing we want to do is get rid of that 4. You could multiply everything by 5, but then you'll have to do everything by 5, and we don't want to get there yet. Maybe later. Subtract both sides, 4 from both sides. Minus 4 minus 4. Notice I'm not also subtracting it from here, because this whole side I'm going to subtract 4 from. OK? Can I erase this now? Awesome. Okay. All right. X over 5 plus 4 minus 4 gives us x divided by 5. That's what we're left over with on this side. Equals 6 minus 4. 6 plus negative 4 gives you 2. OK. Take a look at this. What do we have to multiply by this side of to get the 5 gone? 5. If we multiply 5 times x over 5, you're going to have 5 divided by 5, which gives you 1, and those cancel out. You have to do the same thing to the other side, like that, and you're left with x by itself equals 10, because 2 times 5 is 10. And even though you did it in your head, now you've done it explicitly like this. OK? Any questions on that? If you're not getting it, that's OK. Write it all down, and then we'll practice it a little bit. OK? All right. Here's one we can try. Start with the top here. Leave that one for now. 3x plus 7 equals 5. Solve for x. Same exact thing as the bottom one here, except it's not a division, it's a multiplication. I'll start writing it. Once you get x by itself, you're done solving it, because that's what we're looking for. And the solution set is -2/3. Remember the other day, by the way, I'll go through this one step at a time. First thing I did was I recognized that I had to get that 7 out of this left-hand side. I didn't want to do the multiplication first, because that gets a little trickier if you try to do that. Let's just get rid of the 7. Subtract 7 from both sides. Gives you 3x, because the 7's go away, equals 5 minus 7 is -2. Then I divided both sides by 3 to get rid of that 3x, because in this case it's the exact opposite of what we did with the 5 before. 3x divided by 3 gives you x. So that means I do divided by 3 on the other side. -2 divided by 3, you're done. And x equals -2/3. What you should now do, because maybe you didn't figure that out in your head, like it wasn't as easy as the other ones, plug this back in, solve this, and see if you get something that makes sense. -2/3. 3 times -2/3 plus 7 equals 5. What's 3 times -2/3? 3 divided by 3 is 1. So that means -2 is the answer. Plus 7 equals 5. What's -2 plus 7? 5. Does 5 equal 5? You've just checked your answer, and it's correct. OK? If you do that, if you take the extra minute to check your answer, you will know that you've gotten it right. If somehow this ended up as being like 17 equals 5, you'll go, that doesn't make sense. So therefore, I probably did something wrong, and you can go back and fix it. Okay? A lot of these problems, you can check your answer, and it makes it much easier to get to know that you've got the right answer. If you could check all the answers, you'd know that you got 100 on the test by the end, right? Right. Can't check all of them sometimes, but it's all right. OK, let's do another example. 3 times parentheses x minus 6 plus 5 equals 7x minus 4. OK, it's like we've jumped up to a next level. It's like you solved the last level. We're going to like next level up. Why is it next level up? Well, there's this weird parentheses thing here. And there's an x on the other side, too. And our job is to get the x to be 1x by itself. You could do this a couple different ways. I would do exactly what Nadia is saying. First thing I would do is distribute the 3 through this. Don't do anything else yet. 3x minus 18, because 3 times negative 6 is negative 18, plus 5 equals 7x minus 4. OK? One step at a time. Are there any like terms on this side? The 18, negative 18, and the 5. Yeah. So I would do that next. I would say, let's just combine those right now. 3x minus 13 equals 7x minus 4. All I did was say negative 18 plus 5 is negative 13. OK. Now, what I would do next is I would say, OK, I'm trying to get the x's together, which means I either have to move the 3x from this side to this side, or the 7x from this side to this side. OK? I don't want to do any divided bys yet if I can help it. OK? But I would probably do the, you can also do this one, move this and this first, but I would just do the x's by itself first. Which one do you want to move? 7x? All right, let's move the 7x. How are we going to get this 7x from this side over to this side? Subtract 7x. So we have to do the same thing. Minus 7x minus 7x. We are therefore left with, what's 3x minus 7x? How many x's? Yeah, we have negative 4 x's left. The negative 13, nothing changed with that. Equals, well, the x's are gone over here, negative 4. Okay. Then I would say, OK, now this is looking a little bit more like what we've already done, although the negative's still in there. That might be a little crazy, but we'll get there. How about we need to get rid of that 13? Get the 13 to the other side, because we're trying to get x all by itself so that we can make x equal to something. Add 13 to both sides. Negative 4x equals, because the 13's go away, negative 13 and 13 is 0, equals negative 4 plus 13, 9. Okay. Did you get the right answer, even though you did it backwards? You know what? You probably did it right, just a different way. Or you made 2 wrongs, and then they happen to make it right.
Instead of the 13, I had 18.
Instead of the 13, you added 18. Yeah. And you ended up with 9?
Yeah.
OK. How do we get rid of this negative 4? Yeah, it's being multiplied by x, so you have to divide by that number. And you can divide by the whole negative 4 here. Negative 4 on this side divided by negative 4 over here. That means that that whole thing goes away, and you're left with x equal 9 over negative 4, or x equals negative 9 over 4, or x equals negative 9/4. I don't care how you write it. The homework might want you to write it this way. I don't think so, though. I think you could probably get away with writing it this way. Doesn't matter. The negative can go on any of these numbers because it's just being divided by. OK? And if you want, you plug back in and you check. Let's do that. We'll do that right up here. OK? Here's what is that what we started with? Whoops. We started with this whole thing up here. Sorry. 3x minus 6 plus 5 equals 7x minus 4. I'm going to plug in negative 9/4. This is where it gets a little bit hairy sometimes. 3 times negative 9/4 minus 6 plus 5 equals 7 times negative 9/4 minus 4. OK. Well, you could do a couple things here. You could multiply the 3 through here first. I would probably suggest that, because then you're going to end up with doing fractions, crazy fractions here, and you don't want to do that. 3 times negative 9 is negative 20. You know what? It's not going to matter, actually. Negative 27 over 4 minus 18. Still not going to matter. But anyway, plus 5 equals negative 63 over 4 minus 4. I know it looks, I'm getting like size. It looks a little crazy, but if you want to check it, you got to go through this little thing. And by the way, in your calculator, it's much easier if you want to do it in your calculator. Negative 27/4, negative 27/4 minus, we got to make this 18 over 1 into fourths. So 4 times 18, 8 times 4 is 2, 3, 4, 72 fourths plus 5 equals negative 63 fourths minus, well, this is the same thing, 4 over 1 times 4, 16 fourths. Okay. Okay. Want to see a little trick? Can we make the 5 into a fourths as well? Is it 5 ones right now? Can I multiply both sides, for the top and the bottom, by 4? How about 20 fourths? If everything's divided by 4s, guess what? They all go away. So you've got negative 27 minus 72 plus 20 equals negative 63 minus 16. Hope that works out. Yeah, I think it does. Negative 27 minus 72 is negative 99 plus 20 equals negative 63 minus 16 is going to be negative, let's see, 979. What's negative 99 plus 20? Negative 79. Does negative 79 equal negative 79? It does. We checked it. The checking took longer than the problem in this case, but at least we know we got it right. Okay, so that's one of those ones where you're like, oh boy, I'm going to do that. Okay. All right. Here's what I'm going to do. We're going to take a break now. Didn't quite make it through all that, but that's all right. We're going to take a break now. Come back at 10 after. 7:10. We're going to swap gears a little bit, and we're going to go over the practice exam. OK? So if you hopefully have it from last week, the practice exam. If not, that's OK. But we'll go through any of the problems you want to do so that we can be ready for the quiz tomorrow. It's going to be exactly like this. I mean, there's going to be a couple differences. Obviously, numbers will be different and whatever, but the form for the problems will be very, 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 very similar. OK? So no need to stress about it if you've gone through this a couple times. OK? All right. You can use your calculators for any of the problems on here. But keep in mind, if you just gave me an answer for this, and it was wrong, and I can't figure out anything about how you did it, like none of the numbers are right, I got to take all 7 points off. And that bumps you down to a 93 immediately if you just write the number. So what you should do for problems like this, take the time to write this out. OK? In fact, this one you have to write out. This one says, first, express the number in numbers in scientific notation. Do this one first. 4.2. I can't even see. 1, 2, 3, 4, 5, 6 times 10 to the 6th times 7.5 times 10 to the 1, 2, 3, 4, 5. Okay? If you write that down, that'll be points. Like that's like 1 point right there, or maybe 2 even, depending on what mood I'm in. Right? And then do the actual operation, which is times in this case. What I would do is I'd do 4.2 times 7.5. OK, 0, 1. I would do this on my calculator, by the way. 21, and then 14, 28, 29. Like that. 0, 5, 1, 3, 31.5. Hopefully. OK. 31.5. And then when you multiply 10 to the 6th times 10 to the 5, you just add the exponents. 10 to the 11th. Are we done yet?
No.
No, we got to convert this into proper scientific notation, which means make it so it's between 1 and 10. Move that over to there. It's going to be 3.15. Since I made this smaller, this has to be bigger, times 10 to the 12th. Okay? Is that what the answer? Hopefully that's what the answer says in the back of the sheet, right? OK, that's the kind of way I want you to solve these problems. Why? Because you've got so much work in here. If I had done this wrong and that had been like, if I had said that's 38.2 or something like that, well, this would have been 38.2, right? And this would have been 38.2. And you're going to say, well, that's the wrong answer, right? Well, I would look and I'd go, oh, he just did it wrong here. That's -1. And you get 6 points for this problem, right? I try to make sure to give you the benefit of the doubt. If you just messed up on this, I'm not going to take any more than 1 point off. Why? Because you did everything else right. OK? The problems do add up. I mean, if you'd done this and then you also had this, -10, you'd get 1 off here and another off here and so on. But really, that even if you did that, even if though that answer is way wrong, you'd still only get 2 points off because you showed me what you were doing and I could see it. OK? That's how you should solve these things. And that's why I give you as much time as you really need. 'Cause if you're going to write all this out, it takes a little bit more time. OK? So yeah. All right. Anyway, we don't have to go through all of these, by the way, but we can do some of them. OK? Number 2, perform the indicated operation. Again, you can do the exact same. You can do this on your calculator, but don't screw it up. OK? This is a divided by. So what you're going to do is 1.616 divided by 5.05. I'm not going to try to do that division. Right? In my head, 1.616 divided by 5.05 is 0.32. Thank you. 0.32 times 10 to the, this one I can kind of do, 10 to the 5th divided by 10 to the negative 3rd. 10 to the 5th divided by 10 to the negative 3rd. About 5 of you will do this wrong because you forget. 5 minus -3. When they're divided by, you have to do the minus. 5 minus -3 gives you +8, right? 0.32 times 10 to the 8th. A bunch of you guys will put 2. Okay. Is this done yet? No. 0.32 becomes 3.2 because I move this way. Make that bigger times 10 to the 7. Okay? Yeah. You could do this on your calculator. Just make sure you do it right. That's all I'm saying. You got to remember there's some parentheses involved here. You're going to have to put an end parenthesis. You're going to have to, if you're doing it on your calculator, practice it. Because I don't want to give you -7 points because you just didn't do it wrong. Okay? Questions on this one? Okay. All right. A couple people the other day were saying they were having some trouble with these. These are not really that bad if you just know what the biggest one is if you know the difference between a rational and an irrational number. I messed up on the answers for these. So the answers for these, if it's a rational number, it can't be pi or square root of 2 or square root of 3. Those are all irrational. So anytime I put them for rationals, like for this one and this one and this one, you can't use these answers. OK. A rational number, remember, 2 is a rational number. 3 is a rational number. -6 is a rational number. -6.2. 6 over 5 is a rational number. Those are all rational numbers. When I say give an example of a rational number which is not positive, any of these will work as long as it's not positive. Pick one. -6. There's your answer. Just one thing. You don't need to put a list of them. You just put one. Give an example of a real number which is irrational. These are the things like this. Pi. Okay? I could say give an irrational number that's negative. Negative pi. Right? That's negative irrational number. Right? Give a rational number that's not an integer. A rational number that's not an integer. That's an integer. That's an integer. That's an integer. That one's not. There you go. -6.2 or 6.2 or 5 halves or whatever else. A rational number that's not an integer. 6/2 would not work. Even though it's in fraction form, you can reduce it, and it is an integer. But that's actually an integer, even though it looks like it's not. It's just not reduced. Example of a rational number that's not a natural number. Natural numbers start from 1. Anything that's not 1 through infinity, right? 0, -2, -4, 4.5, you know. No, sorry, -4.5. Anything that's not a natural. Yeah, no, that would work. 4.5 would work. It's not a countable number from 1 to infinity. Okay. All right. Anybody still have questions on these type? I think this one should be a slam dunk 4 points. All right. All right. Okay, these ones. This is where it's just, do you know how to do your fractions and your orders of operation, right? So 3/7 plus 2/3, well, you're going to have to do what? Common denominator. In this case, it's 21. And this takes a little practice to recognize that. But if you multiply them together, you'll always get a common denominator. You might have to do more reducing, but you'll always get that. To get this to 21, you have to multiply the top and the bottom by 3. 3 times 3 is 9, and 7 times 3 is 21. Plus, to get 3 to 21, you've got to multiply by 7. 7 times 3 is 21. 7 times 2 is 14. And then now you can add the numerators. So you get 9 plus 14 is 23 21s. Don't even bother reducing that unless you want to. Well, it says reduce whenever possible. I will probably not take off points if you don't reduce. Okay? I mean, if it's a really simple one, I might go, come on. Then I'll look for some other place to take points off. I'm just kidding. I'm not that vindictive. This one, this is really, if you restate this, this is really 1 divided by 8/9 minus 2/9. Why? Because that divided sign is like over the whole thing here. So it's really like that. But can you subtract these two if they have the same denominator? Sure you can. 8/9 minus 2/9 is 6/9, and you've still got the 1 divided by that. This is where you need to know how to do your division. Yeah, you got to flip it, right? 1 over 1 times 9 over 6 is really what this is. Or you just flip it. That equals 9/6. And this is the one where I'd go, come on, you can reduce that, right? 3 goes into 9 3 times, 3 goes into 6 2 times. I wouldn't take points off if you didn't. But that's what you do. Okay? All right. What's anything divided by 0? Undefined. Undefined. You should write undefined. Or if you want to be really fancy, you can write the little bracket thing, and that actually means undefined. Looks like a 0 with a slash through it, but no extra points for it. I'll probably give you a bonus, so you'll have a chance to get extra points. Okay. I don't know what it's going to be yet, but figure it out. What's the square root of a negative number?
Does not exist.
Undefined. Well, we're going to say undefined in this case. It is an imaginary number, but we're just going to say undefined. Okay. This one, standard, stock, the order of operations. 2 times 11 first, then you do -3 plus 22 minus 6, you're done.
What's the -16 then?
So the first thing you do is to multiply -3 plus 22 minus 6. And then you do -3 plus 22, -19 minus 6 gives you 13. Good? I think that's the right answer. OK. All right. Let's spend some time on this next one, because this is during the review session, this came up as like, oh my gosh, I don't know how to do these. OK. All right. OK. What we're trying to do with this is simplify these so that we can hopefully add some of these terms together. OK? Remember what the first thing I said to do when you're trying to simplify the square roots? Write out all the square roots. I write out all the numbers from 1 to 10, or 2 to 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I do all the squares of those numbers. 4, 9, 16, 25, 36, 49, 64, 81, and 100. And then this is the column I'm going to look at when I'm trying to find out if any of these go into any of these guys. OK, a couple other things on this. 3 square root of 48 means 3 times the square root of 48. OK, that's what that means. The square root of 27 means 1 times the square root of 27. So whatever we break this down into gets multiplied by whatever out here. That was kind of seemed to be a point some people kind of got confused on. OK? So let's try to do this. What we're trying to do is simplify this expression. OK? All right. Square root of 48. Do any of these go into 48? 16 does. Anything else? 4 does. Pick the biggest one. If you don't pick the biggest one, you'll have to do it again, which is fine, but pick the biggest one. 16 goes into 48 how many times? 3. Divide on your calculator if you don't know. 3 times the square root of 16 times 3 is what this turns into. OK? You can rewrite this like this. 3 times the square root of 16 times the square root of 3. Do we know what the square root of 16 is? It's 4. 3 times 4 times the square root of 3. Can you multiply those together? You can. 12 times the square root of 3. Can't do anything else. And that's just this part. Do the same thing for the plus 27. Square root of 27. What goes into square root of 27 of this column? The 9 does. So this is going to be plus the square root of the square root of 9 times 3. Or you can write it like this, square root of 9 times the square root of 3. Can we take the square root of 9? Yes, that's going to be the 3 plus 3 times the square root of 3. We're done with that part. Same thing, and that's this one. We're going to do the final one over here. What goes into 75 in this list? 25, nothing else. This is going to be 2 times the square root of 25 times 3, which is the same as, this is minus actually, minus, this is going to be 2 times the square root of 25 times the square root of 3. Same drill. And I'm trying to repeat it a million times so you remember. Minus 5, and the 5 times the 2 is going to be 10, and the square root of 3. OK. So now we're left with 3 square root of 3 minus 10 square root of 3. Can you add or subtract these terms now? If they've all got the square root of 3, you can. 12 plus 3 is 15 minus 10, 5 square root of 3. And that's your answer. OK. Whew. Okay, I think these ones are worth how much each? 5 points each. So that's a lot of work for 5 points. More than some of the other problems, but you know. OK. Any other questions on this one? OK. If you do, stay around after class and we'll go over some more. OK? Or just practice them and redo them.
Is this how many questions are being tested?
This is how many questions are going to be on the test. OK. Properties of exponents. 11 to the 0. We said anything to 0 equals 1. Negative 5 squared. This is what we did right at the beginning of class today. This means negative 5 squared. 5 squared is 25, negative 25. It's one of those things you do have to remember. 3 to the 4th times 3 to the 5th. What do we do to those ones? Add 3 to the 9th. 7 to the negative 2. Negative exponents means you divide by it. 1 divided by 7 squared, which equals 1 divided by 49. Leave it like that. Or divide it on your calculator. I don't care. OK? All right. Questions on those ones? OK. By the way, I lied to you on last week's video. I had to switch it on the video. I had to put a little blurb on there. 0, I looked it up. 0 to the 0 is actually 1, not undefined. You'll never see it, but it turns out it's 1. It's kind of like 0.9999 equals 1. It's something different. Yeah, Dwan. Can you what? No notes. No, sorry. Good question. I forgot to say that. Yeah, somebody tried that in the last class. They're like flipping through notes. I'm like, what are you doing? It's like, I'm looking at my notes. I'm like, no. So, yeah, all right. It's funny that it took that long for it to come up. See, if you hadn't said anything, you could have started with your notes and then, oh well. All right. Property of real numbers. Property of real numbers here. I don't want you to solve any of these. Don't do any math on these parts. Just tell me what's going on here. What is this one? Distributive, right? This is the distributive property. That's 4 points for writing DIST period, right? Or distribute, whatever. This one where you've got these guys associating with each other and these guys? Associative. Yeah, see, when it's got parentheses like this, that's a tip-off. It doesn't have to be that, but this is a tip-off. 3 plus 5 in parentheses here means these two are associated with each other. Over here, these two are. And you'd answer this differently. You'd say this is 8 plus 7 is 15. And here you'd go, this is 3 plus 12 is 15. So you do them in a different order, but it works out to be the same answer, 15. Right? So it's associative because these guys are associated with each other. Now they've moved. This one, this is the identity. And you probably should say, of addition. We should probably say that for this one too. Associative property of addition. OK? Associative property of addition. I guess I could take a point off if you didn't say addition. But it is definitely addition. Yeah, you should. I will. This one you don't need to. You just need to say distributive. This one you have to say of addition or identity of addition. OK. Let me just give you another example. Let's say AB equals BA. Which one is that? Nope. Commutative. See how they moved? Flipped, right? Commutative of multiplication. Okay. ABC equals ABC, like that. Associative, right? So, OK, you guys got this stuff. Multiplication, right? Good. All right. Express as a fraction. All right. This one, all right, use your calculator. I don't really care. You could actually divide it out using the long division. I don't really care if you do that. OK, just do 7 divided by 20 on your calculator, which gives you what? 0.35. You're done. Easy question. 4 points for that? That's crazy. Express the decimal as a fraction. This one you have to go, look, 0.47. How many things are on that side of the decimal? 2. 10 squared is what? That's where the 2 comes from. 100, this is going to be 47 out of 100. Done. You can reduce it if you want. Don't worry about it if you don't. The point is you know how to do that. Okay? All right. Good. So that's it. Holy smokes, that's it. OK. So look at how much time that took us. 20 minutes. That was easy. Now, so you're going to all do it in 20 minutes tomorrow, right?
Sure.
You can take more time than that. But you should not take more than 50 minutes. If you need to, fine, but I don't think you will. Question, Tony. 8 plus a bonus.
I'm not so scared of tomorrow.
No. OK, this shouldn't be a scary one. The final will be a lot longer. Sorry. And the other quiz will be a little longer, but that's it. OK, any questions on the practice test? Okay. Many of you will get 104 points or whatever, right? Because you'll get the bonus right and the thing. Okay, many of you will. Some of you will get 70-something, but I hope not. OK?
Well, we got to get the pass.
Passing grade in here is 65, I believe. It's either 60 or 65. Now remember that. No, let me give you one heads up. In the last class, which is also about 18 students, there were, let's see, going into the final, I think something like 12 of them had, or 13 of them had A's. Going into the final. Coming out of the final, 6 had A's, because they did pretty poorly on the final. So just bear in mind, the final's the hardest part of the class. We will spend lots of time practicing it, but that's the hardest part of it. You can drop your letter grade pretty easily by doing it. So don't let me scare you. Just let me give you a warning that it's going to happen. Too late? Sorry. Final is 35% of your grade. Yeah. And the quizzes are, what did we say, 18% of your grade each. And the homework is something like 20 times 600, 16% of your grade or something. So, yeah. And then attendance is part of your grade, 15%. But only like for instance, for those of you who are going to have to miss tomorrow, if you miss class because of a duty, that's not points off. Like there's no points off there. You miss class because you're just like, oh, I forgot. You know, I'll probably if you do that more than once or twice, I'll be like, yeah, well, you're getting points off.
So you take points off for being late?
I don't know. I mean, just don't be late. So that's right. Okay. All right. Any other questions on the practice quiz? Okay. Starting off with a pretty easy one, I think. It'll be on by tomorrow morning, unless my internet does something funny. It takes forever to upload videos, you'd imagine. Forever. Like I started tonight, and hopefully by morning it's done. Question? No, I think I said it's due at. I think it's due at 5 p.m. Tomorrow. Yeah.
So on the day that it's due at 5
Yeah.
p.m. that day.
5 p.m. that day. I mean, if it comes down to it and you need a little extra time, email me. But I'd rather you don't get delayed on your homework because that just puts you back behind.
About the homework.
Yeah,
make
keep.
sure there's no like submit button, just the
Just
save button.
right. You do not have to do any extra submission.
I wanted to make sure it wasn't just like having it done and not submitting it.
No. Do you think I'd be that kind of teacher who'd be like, you didn't push submit, you're not gonna? Yeah, no.
Oh my gosh, that would ruin my life.
I could be that. Yeah, I feel. All right. Let's see. Let's get back in the mindset of algebra. Okay. Try to solve this for x on your own. And I know we just took a whole 20 minutes out of not doing it. Try to solve this on your own, and then I will start solving it in a second too. There are many ways to solve this. I will do one of them. What am I doing? No, but you'll know you got it right. This is not going to be on the quiz.
Dang it, I feel like I'm okay at this.
Then it'll be on next week's quiz. Not going to be on tomorrow's. On next week's. Okay. Did everybody get 8? Not quite yet. Let me go through the steps, just so you know the steps. Write down all the steps, all right? First thing I did was I looked at this and I said, all right, I've got to get the 5x and the 12x together. So I'd better get the 5x. It doesn't matter. You could have moved the 12x over, but I'm going to do the 5x. Subtract 5x from both sides. That will get rid of this 5x over here. I do that. I say 12x minus 5x is 7x plus 10 is still there. Equals, well, 5x minus 5x is 0 x's, so it's gone, plus 66. And then it's like rinse and repeat, right? Now I want to get the 10 to the other side, so the x is going to end up being by itself. Subtract 10 from both sides. 10 minus 10, so you're left with just 7x. 66 minus 10 is 56. Now you're left with 7x equals 56. Well, you got to get rid of that. You got to break apart that 7 and the x. 7x divided by 7 gives you x. So that's what we want to do. Divide both sides by 7. 7x divided by 7 is just x. 56 divided by 7 is 8. Done. Check your answer, right? 12 times 8 plus 10 equals 5 times 8 plus 66. Boom, boom, boom. You do it. You end up with 106 equals 106. Check. If you do that, you'll know you got it right. Unless you do the check wrong. And sometimes, one of these days, you guys should look up the Byzantine general problem. If you, let's say you and another, but you were in a battalion and another battalion, we were trying to attack some, I don't know, fort somewhere, right? Trying to attack it. And yet one of you is on one side of the fort and the other's on the other side of the fort. And you only have communication by messenger. And once you send a messenger away, the same messenger doesn't come back, right? So how do you guarantee that both you and the other battalion know when to attack? Let's say one guy's in charge and he's in battalion 1 and he says, okay, to his messenger, go tell the other battalion we're going to attack at dawn tomorrow. And the guy runs away and never comes back. Okay? Well, what do? How does the other battalion respond? So that you know. So the other guy sends a messenger back, right? So how does the other one know that his messenger made it to you? You have to send another one back, right? But how do you know he got that message, that you got the message to begin with? Yeah, you don't. So it's a little tricky. But anyway, the point was, you can do your check wrong too. But at least if you end up getting the same answer for both, you'll know that you're right. Okay? All right. Here's another example that will, in some sense, look a little confusing. Okay? I want you to try this one. And nothing's confusing about the algebra. It's the answer that's confusing. 12x, I'm running out of ink. 12x plus 10 equals 5x, that's the one I just did, sorry. 3x minus 7, 3x minus 7 equals 3 times, in parentheses, x plus 1. Okay? Solve that for x. I'll give you a hint. You better deal with that parentheses first. You better do the distributed property first. Oh, thank you. Plus 3. Thanks, Aaron. Anybody else end up with an answer that just does not make sense? Yeah, I ended up with negative 7 equals 3. If you did it a different way, you might have ended up with, you might have done something like, oh, OK, I'll add 7 to both sides. Equals 3x plus, well, I'll just add 7, sorry. I'll add 7 here, plus 7. That's going to be 3x equals 3x plus 10. And then I'll subtract 3x from both sides, minus 3x, and I'll get 0 equals 10. Big old question mark. What this means is that there is no solution for this problem. How do you know? Well, think about it this way. Once we did this and got this far, 3 times something minus 7, we're saying somehow is equal to 3 times something plus 3? That doesn't make sense, right? There's no way to actually make that make sense. Okay? So in this question, the answer is no solution. Right? And by the way, a lot of times, sometimes people will write it like this. A lot of times you'll see how the difference, the slash is that way. I don't really care. I'll know what you mean when you say that. But some people, that means 0. That's actually kind of a backward 0, so that's actually no, it means no solution. So what you should say for this, what's that? You can write no solution. Right? Okay? Write no solution. Okay? It could be either. But what did you get? -7 equals 3? Or yeah, that's the same thing. -7 does not equal 3, so there is no solution. X was gone, so you went, oh my gosh, X is gone. OK, this is one type of like weird problem. Let me show you another one that's a little weird. Okay, you will have to be able to do both of these so that to get the answers on some of the next quizzes. For instance, 4x plus 1 minus 5x equals 5 minus, in parentheses, x plus 4. X plus 4. Solve that for x. I'll give you a sec. Just don't look up at the board. Oh yeah, I don't give you enough time. That's right. Naughty, don't forget to leave.
Yeah. Yes.
Take your time. I'm not holding you up. What do you think you'd do first on this one? Any idea? First, look for parentheses, right? And you're going to look at that and you're going to go, OK, I better make this minus distribute through the parentheses. By that, I mean you're going to say equals 5 minus x minus 4. Did you do it wrong? What I did there was just said this is actually -1. And see how we distribute through these things? The distributive property? That's what you have to do. Okay? I think we're going to have to practice some like one-on-one time here where we do some, or you sit down with Travis and say, how do I do this stuff? Yeah, that's good. That's good. When you get to these ones on the homework, you'll see what they're doing. Yeah, it'll take some time because you got to practice it with the homework, but you'll do it. Okay.
Are we supposed to get an answer, or is this supposed to be
Good question. Let's see. The next thing I would do here is I would say -x plus 1 equals, and then 5 minus 4 is 1 minus x, which really is the same thing. You can write it like this. 1 minus x equals 1 minus x. Or you could do this. You could say 0, or sorry, add x to both sides, and you end up with 1 equals 1. Now, is that a true statement? Before, when we did it in the last problem, it was a non-true statement, right? We got -3 equals 7, or 0 equals 10. That means there's no solutions. This means everything is a solution. No matter what x you put in here, you will always get this side equal to this side. You can try it. Let's put 0 in. 0 plus 1 is 1. -5 times 0 is 0, so we're left with 1. 5 minus 1, let's see. 0 plus 4 is 4. 4 times -1, -4. 5 minus 4 is 1. No matter what answer you put in there, you will always get a correct left side equal to the right side, any number. Okay? So what that means in this case, the solution set, we write it like this. We say it like this. We say x for all x. Or you could just write every solution. And I want you to write that down something along those lines. Like you could say this formal way, or you could say every solution. Don't say no solution, because that's wrong. There is a solution. In fact, every number works. No matter what number you put in there, works fine. If we put 1 in there, it'd be 4 plus 1 is 5, minus 5 is 0. 5 minus let's see. It ends up being 5 over there as well. So 5 minus 5 is 0. 0 equals 0. Any solution works. Okay? Every solution, any solution, whatever you want. Just make it known to me that you understand that any numbers will work. Good? All right. OK. All right. That's that. OK, let's see. We did that one. All right. Here's another one. 2x divided by 5 plus 3 equals 29 divided by 5. You could do this with the trick I showed you a few minutes ago. I didn't go over it very explicitly, or I did, but I didn't do it slowly enough. Yeah, if you get 5 on the bottom of this one, you can do this real easy. How do you turn 3 over 1 into something over 5? Multiply by 5 on the top and the bottom. 15 over 5. So this will become 2x over 5 plus 15 over 5 equals 29 over 5. And if you get everything where it's the same on the bottom, just all the 5s on the bottom go away. And you're going to get 2x plus 15 equals 29. And then you're going to subtract 15 from both sides. And you're going to get 2x equals 14. X equals 7. That's one way to do it. There's lots of different ways. You could have subtracted 3 from both sides. And then you'd have to move it over here. And you'd still have to turn it into a 15. Right? I'll do it. Tell you what, right here, I'll do it as if you did that. Let's say I took the same thing and I just subtracted 3 from both sides. Wouldn't I get 2x over 5 equals 29 over 5 minus 3? So I subtracted 3 from this side, and I subtracted 3 from this side. Now I probably want to turn that into a 15 over 3 now. And I get 2x over 5 equals 29 over 5 minus 15 over 5. Fine. 2x over 5 equals 29 minus 15 is 14. 14 over 5. How do I get rid of the 2/5 times x? 2/5 times x. And I want to get rid of the 2 and the 5 in one step. What am I going to multiply by? 5 over 2. Right? Because 2 times 5 is 10, and 2 times 5 times 2 is 10, and 10 divided by 10 cancels out. So if I did this side by 5 over 2 and this side by 5 over 2, I get, cancel, cancel, x equals, well, you can cancel the 5s there, or you can just do it out. 14 times 5 is 20, let's see, 570 divided by 10. What's 70 divided by 10? 7. It gives you the same answer. Lots of different ways to do these.
How do you get the 7 on the other side?
Here,
Like from the 14 and then
Here?
to the 7 on this side.
here.
Oh, you're the 2 instead.
Yeah, I divided by, oh, you know what? I did skip a step here, didn't I? I kind of skipped the fact that I'm trying to do it too fast. Divided both sides by 2. That means that's going to become x equals 7. 14 divided by 2. Yeah, thanks for pointing that out, Amy. Okay. You get a little gold star. Anybody who's corrected me, you get a little gold star. All right. Aaron corrected me. Tony corrected me. OK, let's see. That's that one. OK, let's try this one. 2x divided by 5. 2x divided by 5, like this. 2x divided by 5 plus 3 equals 4 divided by 7. Now you can't do the tricky stuff as easily. give you a hint on this one, Andrew. I'll give everybody a hint. Convert that 3 into something over 5. Or subtract 3 from both sides first. One or the other. Whichever one you want to do.
You subtract 3 from the top of 2.
I would do that. I would subtract 3 from here and subtract 3 from here. In other words, this whole side minus 3. Let me rewrite it like this. 2x divided by 5 plus 3 minus 3. What's left over? 2x plus 5 is left over, right? That's when I write it like this, I'm just writing it underneath to know that I'm taking this whole side and subtracting 3, and this whole side and subtracting 3. So what I'm left with here on this side is 2x divided by 5. And what I'm left with on the other side is 4 over 7 minus 3 over 1, or just 3. And now I want to do this fraction part and deal with that. 2x divided by 5 equals, well, 4/7. To get this into something over 7, I got to multiply the top by 7 and the bottom by 7, because I can do that. Minus 21/7. 2 divided by 2x over 5 equals 4 minus 21, negative 17 divided by 7. Okay. What's wrong, Amy? Processing. Yeah. We'll learn how to deal with these ones really easily in a little bit by doing this thing called cross multiplication, but we're not going to do that quite yet. Okay. What I would do next is try to get rid of the 2/5 by multiplying both sides by 5/2, kind of like what we did before. That cancels out, and that cancels out. We're left with x. X equals negative 17 over 7 times 5 over 2. We have to know how to multiply fractions. You multiply the tops to each other and the bottoms times each other. 17 times 5 is 3. Let's see. Sorry, yeah, 5 with 3, 85, negative 85 over 14. And that's actually your answer. Now, this is one of those ones where if you want to check it, well, 2 times negative 85 over 14 divided by 5 plus 3, and you should get whatever 4 divided by 7 is. Checking it's a little trickier as well.
You said that's negative 85?
Negative 85 over 14. These things get a little trickier. Yeah. Okay. All right. Questions on this one? We will do lots of practice. You will do lots of practice on the homeworks for these. Okay? And I'll give you some practice there as well. All right. Let's take another break. Come back at, what do you think? 10 after? 10 after. All right. So let's get back to it. We have been talking about algebra and solving some of these equations and how to do that. We're going to switch topics slightly, not really, but slightly, to this idea of ratios. Okay? Ratios. We actually did a ratio problem on the first day of class when we looked at that problem with the potatoes, where we did the recipe. We're going to get into another one of those here. A ratio compares quantities by division. Okay? Here's an example. there are 850 soldiers at CLDJ. There's probably a lot more now. You crazy 1st and 63rd people come in and ruin the ratio. There are 850 soldiers and 700 sailors, let's say, and a couple of Marines and Air Force people. Okay? All right. What's the ratio of sailors to soldiers? 700 sailors divided by 850 soldiers. If you reduce that by dividing by 10 and then dividing by 2 and by 2, you end up with 14/17. The proportion is 14 to 17 of sailors to soldiers. I just divide, well, I'll write it out. 700 divided by 850, I'm trying to reduce it. First thing I'm going to do is divide both sides by 10. That's going to leave 70 divided by 85. Now let's say I divide by 5. I said 2. I should have said 5. 70 divided by 5 is what? 70 divided by 5 is 14. And 85 divided by 5 is 17. That's how I got it. Okay? What that means is you start taking soldiers, you take 17 of them, and then you take 14 sailors. Then you take 17 more soldiers, then you take 14 more sailors. By the time you get down to at the end, you're not going to have any of, it's been an even number, right? Because for every 14 sailors, there's 17 soldiers. Okay? About the same number of brain cells. Okay? Just kidding. All right. Remember, I'm in the Navy, remember. All right. A proportion, okay? A proportion, this pen is really dying. Proportion, okay, is a comparison of ratios or an equation of ratios. An equation of ratios. Okay? For instance, A divided by B equals C divided by D. A divided by B is a ratio. If we say that's equal to C divided by D, we've now got a proportion. Okay? Here's an example. 1/2 equals 5/10. Is that a correct statement? It is. 1/2 equals 5/10. Okay, that means that this side is equal to this side, and this is a proportion. It's a ratio compared to a ratio. Okay. Now, if we have A over B equals C over D, okay, what's the common denominator here? There isn't one yet, but we can make a common denominator. What's the common denominator here? 10. Let me do a different example. Let's say that it was, it's not a good example. This is a tough one because it's 1 over 2. Let's see. 1 over 3 equals, let's see. This is going to be hard to make a common denominator. The common denominator, 1 over 2, let me do it this way. 1/2 equals 5/10. Yes, 10 is the common denominator in this. Like you can make it both sides into 10. But couldn't you also say that 20 is the common denominator? Sure, because they both go into 20, right? So if you have A over B equals C over D, you can say that BD is the common denominator. Okay? And therefore, if you multiply, to get BD here, you multiply D on the top and D on the bottom. D divided by D gives you DB on the bottom, because that's the common denominator, BD and DB. Which property is it? BD and DB? Not distributive. DB equals BD. It's the commutative of multiplication. Okay. So DB equals, then over here, to get DB, you multiply the top by B and the bottom by B, because B over B is 1. And you're left with AD over DB equals CB over dB. Okay? And what happens to the d's here? They can't, wait a minute, we already did that. Sorry. You can, let's see. BD. Oh, you know what? Yeah, I guess I'm doing this. I guess I'm doing it a little bit wrong. Let me redo this one. Let me redo it. The common denominator is BD. Okay. So if we actually multiply everything by BD, sorry, this is a little confusing now. BD, okay? And this side, we do the top and the bottom by BD and BD, okay? Now what we're going to get is we're going to cross out the B's here. I still did it wrong. I'm being a moron here. There we go. All right. Multiply this side by BD and this side by BD. The B's will cancel out here. The D's will cancel out here. And we end up with A times D equals B times C. All of that, because B and C are here. All of that said, let me stop confusing me and you guys. A over B equals C over D. What we can do is this thing called cross multiplication. What it means is you get that times that equals that times that. It's called cross multiplication. Cross multiplication. And it makes it really easy to solve some of these problems. Okay? AD, because this means that A times D equals C, B times C, or C times B. What it does is it turns fractions into multiplications, which are sometimes a lot easier to deal with. Okay? So that's what we can do. And it will make it easy to solve some of these. Yeah, go ahead. Yep.
Now, since you cross-multiplied that, then what was the purpose of putting the BDs or?
Yeah, this was just to say that if the common denominator is BD, I can multiply this side by BD and this side by BD. And therefore, you end up with the denominators going away. That's all it was. Let me do an example of how you'd use this to solve a problem, and then I'll stop confusing you. OK. All right. Here's the example. I need a new pen. 72.
You want me to go get you one?
No, sorry. 72 divided by x equals 8 divided by 5. OK. Before, we might have said, all right, let's multiply both sides by x. And then when it goes over here, we're going to multiply both sides by 5/8 and whatever. Much easier way to do this. Cross multiply these. And you get 8x equals 72 times 5. 0, 1, 150. That was, now it's all of a sudden no fractions are left, and we're pretty much down to one more step. Divide both sides by 8, and you're done. X equals 150 divided by 8, which is 75 divided by 4, I guess, which is 25. 72 times 5, because I'm cross multiplying. Did I do it wrong? Who said 150? That's my problem for listening to you. 72 times 5 is 360? All right, thank you. And then 360 divided by 8 is, let's see, 45? Should I listen to you?
No.
How about 45? All right. OK. 72 times 5. Yeah. OK. All right. So let's try another one where it's a little trickier, but same idea. OK. Same idea. 12 divided by x minus 5. Notice this is all underneath the division sign here. Equals negative 18 divided by x. Now, you're trying to solve for x, and you say, oh man, this is going to be a pain, because you got to do, you got to do some divisions here, and you got to do multiplications. Cross multiply. 12 times x and negative 18 times the whole quantity x minus 5. 12 times x equals negative 18 times x minus 5. Okay? 12x, you have to distribute this. Negative 18x plus 18 times 5. Let me see if I can do this. 0, 4, 5, 90. OK, I'll believe you this time. Negative 18x plus 90. Now we're going to add 18x to both sides to get rid of the 18x over here. And we're left with 20, 30, x equals 90. And then it's pretty easy. Divide both sides by 30. And then you're left with x equals 3. Okay. Lots of steps pretty quickly, but write it all down and go back and check. And I'm going to check, by the way. 12 divided by x minus 5. 3 minus 5 equals negative 18 divided by 3. 12 divided by negative 2 equals negative 18 divided by 3. 12 divided by negative 2 is negative 6. Negative 18 divided by 3 is negative 6. Check. Good? Okay. All right. Here?
Yep.
See how I divided this side by 30 and this side by 30?
Oh, I see.
And then 90 divided by 30 is just 3. Okay.
So what happens if you don't put them on opposite sides of the equal? If you just put them together, how do you know which one's on top and which one's on bottom?
I don't understand your question. How do you know which one's on top and which one's on the bottom?
12x would be 12x over.
No over anymore. We're multiplying, cross multiplying. This equals this. Right? So in this case, it's 12x, which is this times this, equals negative 18 times x minus 5, which is this times this. Right? OK. All right. Let's do an example. This is like one of those word problems. Okay? Here's kind of a word problem for you. Property tax. Anybody own a house in here? Help people? Yeah. They're expensive, right? Tax is expensive. You never think about it until you own a house. You're like, wait a minute, what's this extra cost? OK, property tax on a $220,000 house, which, if you're like me and you live in Boston, that's like you can't even buy a matchbox for that, right? $220,000 house. The tax is $1,200. Okay? Assuming the same tax rate, okay? What is the tax on a $320,000 house? Tax on a $320,000 house. Okay? You can do this with a ratio. Okay? You can say $1,200 for the $220,000 house equals some amount of tax for the $320,000 house. And you see how this actually hopefully makes sense intuitively to you, because you go, oh look, 1,200 divided by 220,000 is going to be the same as some number divided by 320,000, and that number is just going to be the amount of tax you have to pay. This is the same rate. Okay? How would you do this? Cross multiply. This is one where this one you might want a calculator to do that one out, but it's not too bad. 220,000 x equals, let's see, 32 times 12, 4, oh, I'm not going to get this right. 384? 384 million or something like that. There's a lot of zeros in there. 1, 2, 3, 4, 5, 6. Okay? And then divide both sides by 220,000. 220,000. And you'll get a lot of zeros go away. 0, 0, 0, 0. And then you get 38,400 divided by 22. Should give you $1,745.45. Yeah. Okay? That's not bad. That's not too bad how to do that. It's just you got to recognize that it's a ratio problem. Okay. What's that? The tax rate's not too bad either, yeah. Less than 5%. No, not quite. A little more, 6%.
So for putting which number on the top or the bottom doesn't really matter as long as
In this case, it does not matter. Yep, you could have done it the other way. You could have said 220,000 over 1,200 equals 320,000 over x, and you would have still cross-multiplied, and you still would have gotten the exact same thing. Yep. So it doesn't matter in that case. Yep. Sometimes it does matter, but not in this case for these kinds of problems. OK. Whew. Last 4 more pages of notes. But there's a lot of writing on them because these are now word problems. OK? Word problems.
Is the stuff that we covered today going to be on the test tomorrow?
No, not at all. We've already gone over everything that's going to be covered on the test, and that was just the test, like just the stuff we practiced. OK? OK. I will reiterate one more time. The final exam in particular is going to be lots of word problems. OK? The word problems, OK, you have to know some, you have to be able to understand how to translate some words into math. Dwan, don't shake your head. You're going to do fine. Don't worry. You're going to do fine. For instance, if I wrote down the sum of a number and 3. The sum of a number and 3. OK? Sum means what? Add. And a number is going to be some variable. So let's just call it x in this case. And we've got 3. So isn't this going to be the sum of a number and 3? It's going to be x plus 3. Right? Those are the kinds of things you have to be able to read and understand. The difference between a number and 6. The difference between a number and 6. X minus 6. Good. Okay. 3/5 of a lump. I should write it out in words. 3/5 of a lump. 3/5 x. Or 3x over 5. That's the same exact thing. Okay. OK, it does get a little trickier. Like, let me give you one more example here. It's a little bit trickier. Sorry, 3/5 x, or 3 over 5 times x. The sum of 3 times a number and 10. The sum of 3 times a number and 10. OK? So this one might be a little tough to, sometimes you might, it's ambiguous in some cases, but in this, you should be able to get it close here. The sum of 3 times a number, the number's going to be what? X, we'll say. 3 times that is what? 3x. And the sum of 3 times the number and 10 plus 10, because the sum part means the and here. OK? 3x plus 10. We get those things? OK. All right. Let's see. Let's try one. Another trickier one. It's getting warm in here again. OK. The difference. So we're already thinking subtraction, right? The difference between the product of, that's multiply, good, product of 6 and a number and -2 times the number. The number. How many different numbers do we have here? One number. The difference between the product of 6 and a number and negative 2 times the number. Same number. This is not a different one. Okay, so we're going to say the product of a number, here's x. This is also x. Same x. Okay, I heard 6x. That's good because that's the product of 6 and a number. Okay, the difference between, so minus 2x. Negative 2x, you're right. The difference between the product of 6 and a number, that's 6x, and negative 2 times the number. Difference between, so negative 2x and the difference. So this is actually going to be 6x plus 2x, or 8x. But you would never have guessed 8x from all that stuff. Right? Yeah. Okay. All right. Let's see. Let's do this one. I'll give you, one more example here. And then we'll go into, and then I'll give you some stuff to hand out, and you can ask all the questions you want about this stuff and work on it. Okay? All right. Okay. Do you ever have something where you have to choose between one plan, let's say it's a health plan or another health plan, you got to weigh the options of both? Or a better example is like cell phone plans, where in one case you get 400 minutes a month, but it costs, $10 extra a month than if you get 300 minutes a month, but you got to figure out how much minutes you're going to use. What's that? And it includes texting and all that. Yeah, exactly. Let's do something like that. So let's see if we can choose between plan A of, say, cell phone plan A and cell phone plan B. Okay? Okay. Plan A. Okay, here's how it goes. $20 per month and 5 cents per minute. 0.05, I'll do it this way. That's 5 cents per minute for charges. Now, let's say it's going to be every minute. There are not some certain, no minutes up front. Or plan B, which is a $5 fee, $5 per month, divided by 10 cents per minute. Or sorry, divided by 10 cents per minute for calls. Okay? Per minute for calls. Okay. So the question is, what number of minutes makes it so that the plans are equal? In other words, if you're trying to figure out which plan you should get, figure out how many minutes you're going to have to call before you decide. Because if you think if it's going to be like 50,000 minutes before one plan's worth more than the other, you're never going to do that many minutes, right? So you'd want to pick one plan over the other. Let's see what this works out to be. Okay? All right. What letter should we use for the number of minutes? Could use X. Why not M? Stands for minutes. We'll remember it that way. You can use whatever you want. We've been using X, and you sometimes use Y, but let's use one that makes sense in this case. Let's say M. M equals the number of minutes. Okay? All right. How much does Plan A cost? Plan A costs $20 per month plus 0.05 times the number of minutes, which we just said was M. So for Plan A, we've got $20 plus 0.005 M. That's going to give you how much it costs per month, right? Sorry, 0.05. Thank you. Okay. There's a good thing on YouTube about a guy who calls up Verizon and tries to explain the difference between 0.02 cents and $0.02. And the Verizon people have no idea. He ended up going to like Canada and trying to find out how much it was going to cost to use his data plan. And they told him they were going to charge him 0.02 cents per minute. And they actually charged him $0.02 per minute. So he had like a $200 phone bill. And he's like, no, it should be a $2 phone bill. And they couldn't get that there was a difference between cents and dollars. It's a really funny video. You look it up. The guy's on the phone and he taped the whole thing, and it's ridiculous. But anyway, thank you for correcting me on that. OK, plan B is what? $5 a month plus 0.10 m. And we're trying to figure out when they're equal to each other. So don't we just set these two things equal to each other? Forget about the A and the B now, because that just means the plan. And now we've got this. Can we solve for m? Have we been doing that all day? We have been. OK, let's do it. Let's see. What do you want to do first? Let's move the 5 over to this side. That's what I want to do first. Subtract 5 from both sides. And you're left with, I'm going to have to write it up here. I'm going to do it here. You're left with 15 plus 0.05 m equals 0.10 m. OK? Now let's subtract 0.05 m from both sides. And we're going to get 15 equals, that's going to be 0. So this is going to be 0.1 minus 0.05 is 0.05 m. How do we get rid of the 0.05 times m? Divide, because divide's opposite from multiply. 0.05 divided by 0.05. 15 divided by 0.05 happens to be 300. So we get 300 equals the number of minutes. So if you call for more than $300 a month, or 300 minutes a month, one of these plans is going to be worth more. Which one is it? That would be the next question, right? Right now we know that 300 is where you break even. OK? So let's think about this. If 300 is where you break even, at 301, how much is this plan going to cost you? How much more, I should say? 5 cents more. How much is this one going to cost you? 10 cents more. So which one's better if you use more than 300 minutes? A. You pay a lot more up front, but then you can use lots of minutes and not charge as much per minute. But after 300 is where it makes sense. If you're the kind of person that only calls your mom once a week, right, like me, and I'm probably a bad son for doing it, but you call your mom once a month, right, or once a week. If you only do that and you only spend like 120 minutes per month, this is a better plan, because you're not going to quite make that 300. You're not going to make that 300-minute plan. Yeah.
So if you did one less minute,
Yep. If you were to do one less, sorry, I was wrong. Yeah, this is the one you want for your mom if you do less minutes. If you do more minutes, you're going to want this one.
what's the price difference for that 1 minute?
Yeah. So see how it's 0.05 cents per minute? That's for the extra minute. It's 5 more cents. Let's figure. What? Yeah. Well, you already start with 300 minutes. Look, that's a very good question. How much does this plan cost for 300 minutes? Let's look. $20. We already did it down here. $20 plus 0.05 times 300. What's 0.05 times 300? $15?
Yes.
So this is going to be $35. I wish I could get a plan that cheap. All right, this one, let's do this one. 5 plus 0.10 times 300. What's 300 times 0.10? 30. What's 30 plus 5? 35. Of course it is, because we said that they're equal. So it's $35. And then the next minute you do, for this one, it's going to be 5 cents more. But for this one, it's 10 cents more. So that's why you want to do this plan if you've got more minutes than 300. That's the kind of stuff. Actually, this is the kind of stuff that, in real life, you should be doing stuff like this to figure out which plan is the one you want, right? I mean, sure, you got to decide. You'd be surprised. honestly, I've done this sort of thing before. I mean, it's like when you go and any of these things. Honestly, when you get like your cell phone, if you're not doing these calculations, the guy at Verizon's like, here's a sucker, right? 'Cause he's like, I'll just, you should get the text plan and this, and it's only $82 more a month. And you're like, oh yeah, Now, some kids these days are like, 10,000 text messages or whatever, but per month, but whatever. Okay, all right. So one more little thing, one more quick thing, and then I will give you the stuff and launch you on the practices. Okay. Sometimes you're going to want to solve for a certain variable in some sort of equation. So for instance, this pen is almost dead. There's other pens, but these ones are, let me see if the green one works. It's OK. Probably won't come out on the video. If you have a rectangle or a fence or something like that, OK? The width and the length. Do you remember how to get the perimeter of that fence all the way around? What did you say? No, not quite. It's actually, this side's W and this side's L, so it's going to be W plus L plus W plus L, or 2W plus 2L. OK? All right? And that's the perimeter. Solve for W. You're going to have to do this sort of thing, definitely on the final and on one of the tests, the next test, actually. Solve for W. You got to keep everything else as a variable. That's fine. We still do the same rules. If I want W to stay where it is, I got to get rid of the 2L. OK? What do I do to something if it's being added? Subtract it. Minus 2L, the whole thing. Minus 2L. So this is going to be P minus 2L is what? P minus 2L. Right, you're right. Equals 2W. Now I want to get rid of the 2. What do? Divide by 2. And I'm left with W equals P minus 2L divided by 2. And you got to leave all those other things. So solving for a variable is a very important concept to be able to do, where you're moving the things around using your algebra, but leaving all the variables in place. Okay, we'll practice a bunch of those. OK. All right, so we made it through these things. I have 2 way too thick packets, but you do not have to, again, work on these tonight a little bit in here, but then not until after tomorrow and after you've done the homework for the week. OK? Because I want you to do these problems because there's lots of good ones, but many of them are very similar to your homework ones. In fact, some might be identical. OK?